Hi, the Astro 30 here. I want to adapt that to be able to use this. All that coming up next. Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Now, today I'm going to look at probably a couple of videos here on this. Adding a guitar preamplifier to an existing stereo amplifier, so you can use your home stereo system with an auxiliary input as a guitar practice amp. With a word of caution is not to drive your loudspeakers, unless you don't care about them, that hard, because hi-fi speakers are not designed to be used with guitar, because the excursion is too much. Especially with a bass guitar, you can easily ruin a good set of loudspeakers if you overexert the excursion. Anyhow, with that out of the way, we've got a basic circuit here which I actually found online. Now, the prerequisites to this is it has to be simple and it has to run off of 9 volts. So it can run off of a 9 volt plug pack in this case, or even a 9 volt battery if you so wanted to. I'm going to just go with the plug pack option. So we'll start with that. Up here we've got a 9 volt connector, grounded. This 1N4004 wrong way protection diode. It's also a basic half-wave rectifier as well. Going through this 220 microfarad smoothing capacitor. Now, I'll probably in the final design make that 470, because as most plug pack adapters now are switching, we want to try and remove as much switching artifacts on the DC supply line as possible. That's also being smoothed for any high frequencies by this 100 nanofarad, and that really should be mounted close to the op amp. Now, looking over at the other side of the schematic here, input comes through here through this blocking capacitor, because this is operating on a single-ended supply, so each input point and output point will have a DC potential, around half the supply voltage. So this capacitor at the moment on his original schematic, which I got this from, which I'll link in the description, uses a 100 microfarad capacitor there, which is way too big. So I think it's here at the output after the pot he's using like a 22 nanofarad, so the 100 microfarad is pointless. So for all these caps that are not marked, I'm going to be using, well, 10 nanofarad for the moment. Not 10 nanofarad, 100 nanofarad for the moment, because that's basically the caps I've got. Now, we've got a standard positive regeneration style Class A amplifier formed by this BC548 transistor. We are increasing the gain of the transistor by including this capacitor, this 47 microfarad, which is bypassing this 560 ohm degeneration resistor. Instead of just connecting this common emitter amplifier directly to ground, we're adding in a little bit of resistance there in the emitter, just to keep the transistor in as linear as possible. And this also, I don't think, is right. And I'll tell you why. This 470K should really be coming off of the collector to the base after the collector resistor, and the reason for that is it keeps this transistor in the more linear region over the bandwidth of the audio signal that is being amplified by it. So as the collector voltage rises and falls, so does the base voltage. So the collector effectively controls the base and provides a bit of negative feedback there for the signal to be both stronger in gain and also more linear. As this is not balanced to the halfway voltage point, this is a 68K down here, You could actually include a variable resistor in place of this 470k just to, you know, play with it, just to get it to clip more asymmetrically rather than symmetrically. But for what it is, that's off the topic. However, I'm going to build it up and test it both ways, in the way it's drawn and the way I think it should be. The input impedance of this is around about 50 kiloohms, and for a roughly 200 millivolt input signal we should end up with a 2 volt, this is peak to peak, output signal. That remains to be seen. That then passes through a blocking capacitor here, which is also 100 nanofarad. I've already built this stage up on the breadboard, I haven't done the op amp. This then goes through this pot, which is our master volume control. Now, on his original schematic he had a 470 ohm there, which is not really a standard value, it's more like 500 ohm. But for a volume pot that is kind of a small resistance, so 10k should work just fine and it won't be as fiddly to adjust. Moving on to the op amp stage, which is formed with this NE5532. The original used a TLO71, but there's a reason why I'm going to use the NE5532. For one, it works better at half the supply voltage of 4.5 volts between the input pins and the supply rails. So that's fed into by this blocking capacitor, which will also be another 100 nanofarad capacitor off the volume pot, into this voltage divider here formed by these two 1 megaohm resistors to pin 3 of the op amp. Now, I don't know why he's chosen such large value resistors. Maybe he wanted to set the input impedance to over 500k, I don't know. Just seems 100k probably would have done there. Anyway, that biases pin 3 to half the supply voltage, the same as we did on the input stage. And we have a variable gain stage here. So this variable 50k resistor is our gain pot. And when it's set to 0 ohms, minimum resistance, the total gain of this circuit via this 10k resistor and this 470 ohm resistor is, well, it's resistive feedback divided by resistive gain plus 1. So that works out to a gain of 22.2 something, roughly 22. And when this pot is at its maximum resistance, well, we're going to be in unity gain, so a gain of 1, because you can't get less than a gain of 1 in a non-inverting amplifier. I don't have a 50k pot, so I'm going to use 100k for the test. It just gives a much more smoother range, I guess, the higher the resistance. The lower the resistance, the more pronounced the range is and a bit more fiddly. So yeah, we'll go with that for now. And the final design, I'll probably use a 50k pot. The output formed by pin 1 here goes through this 100 ohm resistor. Now, this 100 ohm resistor just stops anything that this circuit is connected to from causing this to go into oscillation, because this is a high gain stage. So we just want to block any impedance issues that may be present on the other end from causing this to oscillate, because the last thing you want is an amplifier oscillating into a set of speakers. That then goes through this capacitor here, which on his original version he chose a 100 microfarad again, with the positive pointing towards pin 1. I'm not really sure 100% why he went for that large of a capacitance, because if we had a 22 nanofarad capacitor here, as he does on his original schematic, well, we're rolling off the base at the low end quite considerably anyway, so this would make it pointless to be any bigger than, say, 1 microfarad, something like that. Whatever. So I reckon with the capacitors I'm using, the 100 nanofarads, it's going to start rolling off around about the 200 hertz range when it gets below that. So that'll be something I'll look at with the function generator. So that goes through the capacitor, which then goes through these two 100 ohm resistors, which form our left and right outputs. So this is just basically a divider. You don't have to have these resistors here. It may, however, help laying out a PCB if there is a physical component there, so you can run a trace through it. But you could literally just bring the two together off of the capacitor. That's fine. We've got this extra 10k pot, which then can go off to a headphone amp. And that's another reason why I chose the 5532, is because we can use the other channel of the op amp as a headphone amplifier with a couple of transistors to boost the output current. Now, I've done a video on that before, so I'll link that in the description as well. I'm not going to do it in this video. It's the same thing, and I'll probably end up using it. The only difference is we're going to be biasing the input point the same way we are here, so that that op amp will also operate at half the supply voltage and work correctly. That's the only change to it. Other than that, it should work fine. In fact, I should probably build it up in a separate video on breadboard running off of a 9-volt single-ended supply, just to test that it works. So anyway, that's the circuit. There's not much really to it. It's pretty basic. So now all we've got to do is build it and test it. Let's get to it. So there's the input stage built up there on breadboard. It's already got the test leads and stuff connected to it. This wire here, this yellow one, is so I can connect the collector end of the transistor down here to the other end of this 470K resistor. So all I've got to do is just, in the test, just move it from the positive rail, which it is now, over to the other end of that wire. So currently it's with no negative feedback, I guess. And we do have a signal, but it's clipping badly, non-symmetrically too. So I'll have to back that right off until the clipping stops. And in doing so, we can see that the output voltage is nowhere near 2.2, well, 2 volt peak to peak. I'm going to say about there, I guess. About 1.5 volt peak to peak, or 562 millivolt RMS. So currently I don't know what the input voltage is, so I'll put that over to the input side and measure that. I could use 2 probes, but I'm not. Probably would be easier because it's just dual channel scope. There we go. It's very noisy because it's very hard to measure a signal that weak. But if you could make sense of the noise, we could see we're only about 96 millivolt peak to peak, or 18 millivolt RMS, which is considerably a lot lower than what the average pickup puts out. It can be up to nearly a 500 millivolt actually. So I'll put that back down and I'll swap back to the output for the measurement. So there we go. So I'll put that on, I guess, that range. And I will just swap the connection of this end of this resistor to the collector. And as we can see, not much has happened to the signal. However, it actually looks a lot better on the bottom edge and the top going edge than it did when it was connected to the positive rail. It doesn't look as rounded. Don't know if anyone picked up on that, but it did seem to look a little bit rounded at the bottom. So that's actually corrected it for that. So now, if I turn the signal up, we can see we get a hell of a lot more gain out of it, which is also increasing the input sensitivity of the circuit. So I'll turn that right down. And now we start clipping symmetrically at the top rather than the bottom first. Keep going, we'll clip right out. But as I say, you could use a variable resistor there in the negative feedback part to correct this. So it's because you've got a 68K going to ground via the 220 ohm resistor there, so the input voltage at the base is not at the halfway voltage point. So you put a variable resistor in there to bring it around a little bit better. But currently, if I drop that off before clipping, and the weird rounding that it's doing at the top, I'm going to say about there is good enough, because it still looks a little bit rounded at the top, like it's not quite as sharp. So I'll back that off, because that's where clipping is beginning. Is when it gets to there, that's when it clips. Bring it back down, and we actually have more like 1.64 volt RMS coming out, or 4.64 peak to peak. So what is going in? So I'll move the test lead back over to the input, decrease the voltage per division, increase it. So we're more like 60 millivolts RMS, it's less noisy, or 216 millivolt peak to peak, which should be okay with most standard pickups. It may clip a little bit early, but some might actually like that effect. Anyway, I'll drop that back down. I'll swap this back to its output. So now what I've got to do is I've got to build up the op-amp section and test that out. Oh, and that large ass capacitor is a 1000 microfarad 63 volt, by the way. It's the closest I had to hand. It doesn't actually need to be this large. It's just is. So alright, let me get configured here. I'll stick the op-amp over here, I guess. Let me get that part of the circuit built up. It's pretty simple. It's only like 5 resistors and a capacitor, or 2 capacitors. For this test I'm not going to worry too much about the 100 ohm resistors on the output or the pot to the headphone amplifier, but I will build up the basics of the op-amp stage and connect it to the input stage. So I'll get to doing that and we'll come back. But first I need a piss. And a short time later, well actually an hour later, I've been doing other things in between, I've got the circuit built. I have forgotten to include the 100 ohm resistor on the output of pin 1 before the capacitor, but I'll add that in just a moment. That trim pot up the top there is a 20k, the 100k was just way too high. So I've lowered it to 20k. So in the end a 10k linear should do just fine for a nice smooth variance of the gain. And we indeed have a output signal, and that's with the master volume, now it is full up, and the gain set to 0, so gain of 1. We're actually getting a little more out of it than a gain of 1, it's more like a gain of 1.2. But that's okay, so that's minimum gain. So if I back off my master control, and then I increase the gain control, now we've got the signal, and now we're clipping. So getting that before clipping is going to be annoying. So it's right on the end of its resistance too. So I'll set the gain there, and I'll increase the volume till it clips. Now it's starting to clip symmetrically. So back him off so we can get a voltage reading, which is about there. Oh, a wire came out. We're looking at 5.67 volt peak to peak, or 2 volt RMS, which technically speaking should be plenty of gain, I would have thought, going into a stereo amplifier. But okay, so what I want to find out now is what is our lowest frequency we can go before we don't have a signal anymore. So I'm set to 100 Hertz, and I'll adjust the time base. Now we can see that we're outputting considerably less. It's more like 1.27 volt RMS instead of the 2 volt we had before. So I will increase that to 200 Hertz. It's coming back up. So I'll just adjust that again. So we'll change that to 300 Hertz. We're getting close to our 2 volt RMS. So I'll change that to say 320. Very close. So So we'll change that now to 400 Hertz. And there's our 2 volt RMS. So we're starting to roll off around the 400 Hertz mark, which may seem a little on the high side, so the input capacitors could be changed. So we're now at 440 Hertz. So currently it seems to be passing all tests. So now I guess the thing to do would be to hook it up to an amplifier and the guitar and see if we've got a signal output, which we should have. And all we're doing is we're basically bringing this up to line voltage of signal, which is around the 2 volt RMS mark, which is about the output of a CD player, so it should be pretty loud going into the amplifier at normal listening level. It could possibly distort the amplifier too, but we'll find out. So I'm going to start by dropping this all down to 0 gain and turning the master volume down. So now I can disconnect the test equipment, and then I'll hook up the guitar and guitar lead. So the circuit is connected to the amplifier, and I can't hear any unusual noise coming out as hiss, but there is a volume control in between. Yeah, that's working. Alright, I've only got it connected to the left channel. So I'll hook up the guitar now and see how that sounds. Right, the bass is connected to it, but I can't hear it, of course. And it seems to be passing enough bass anyway. So that's with the controls up fairly high. Picking up quite a bit of circuit noise too. It doesn't seem to be distorting that badly. I mean, I'd have to increase the volume of the amplifier a bit more, but so it's distorting. Most of that noise is coming from this circuitry here, so I'll drop that back down. I'll increase the volume of the amplifier. it's properly shielded and properly wired, turn the volume back down again, the circuit will work just fine. It could be improved a little, but for now I'm going to leave it as it is, and I'll reinvestigate this circuit again later and include a headphone amplifier, etc. Excuse me, but for now it works, and that's at 9 volts. I mean, we could easily take the supply right up to 12, maybe 15 volts if we wanted to, and give it a little bit more headroom, so it's at 12 volts now. But yeah, so I might turn this off now. And we'll have a look at a redrawn schematic so we can see a little bit clearer what's going on. Okay, and here's the redrawn schematic on a bit of paper. I've called it the guitar to stereo amplifier adapter. I mean, for what it is, it works, but this just makes it a little bit clearer. We've got our input socket over here, 100 nanofarad blocking capacitor, and I've added this 1K stopping resistor. It just helps with on long lead runs from the guitar, etc. From the lead itself and this stage, which is quite a high gain, I would call it. Yeah, I was operating at about a gain of 4 or 5 or something like that. From picking up RF and amplifying it. All that buzzing we heard was from the guitar lead itself, the circuit layout, and the jumper wire leads that were being used to connect things. Here's a BC548 Class A amplifier stage with the 470K coming off of the collector resistor, which is a 10K to its base, and the rest is the same as what was on the whiteboard. The output comes off the collector. This is a common emitter, by the way. The output comes off the collector via this 100 nanofarad, goes into this 10K log pot, which is our master level control, and it comes back out into this 100 nanofarad blocking capacitor here, into this voltage divider, into the pin 3 positive, or the non-inverting input of the NE552. And pin 4 goes to ground, pin 8 goes to positive. The 100 nanofarad capacitor is drawn close to this IC, so it would be physically close to this IC on a PCB. Here's our feedback network off of pin 1, this 10K, this 470, gives us a gain equals roughly 1.2 to 22. Via this 10K linear pot, which should be more than adequate, wired as a variable resistor, with the clockwise connection going towards ground, or to this capacitor here, which is the AC feedback capacitor, which goes to ground. And the counterclockwise end and the center wiper are wired physically together, so that as you rotate the pot clockwise, the gain increases because the resistance of this is decreasing. As soon as the resistance goes to the counterclockwise position, the resistance is going to start increasing, therefore lowering the gain of this op amp. The output comes via this 100 ohm resistor into this 1 microfarad capacitor, which goes through these two 100 ohm dividing resistors. And even though they look like boobs, they're RCA jacks that are mounted on the back of the casing somewhere. For your left and right outputs to connect to the amplifier, we've got this potentiometer 10K log coming off of the output point 2, which is going to be our phones level, but the headphone circuitry is not shown here. However, I've left room here to actually draw it. It might end up being a bit convoluted down here somewhere, but we'll get there. And the 9 volt DC comes in here, goes through this half wave rectifier or wrong way protection diode, and goes through this 470 microfarad smoothing capacitor, because most wall adapters now are switch mode. So There may be some switching artifacts on the supply, so you want to keep it as low as possible. This could easily be 1000 microfarad, but that's going to take up more height space requirements, especially if you want to try and keep this in a compact little unit. So most of this stuff could be made surface mount, I suppose, and so you end up with a board about probably yay big, and you could do that, but I'm going to use through hole because I'm old school and I like doing it. The next challenge is, if I choose to accept it, and I do as always, is, well, one, to make the headphone amplifier as a single-ended supply use, which means I'm going to need an output capacitor as well, but it should be possible to do. I believe there's a silicon chip article that was released around about 2006, I think it was, which was their guitar preamplifier 4-channel mixer Mark II, and that was using a single-ended supply and a lot of this voltage dividing on inputs pins of ICs to make the circuit work, and it had a headphone amplifier in it that was on single-ended. So I can just look at that circuit for reference. It's no different than the bipolar version. It's just that the ground point now is the negative, not the halfway voltage point. But that's something to explore in another video. And the second challenge is to lay out a PCB, making it single-sided only, with no link wires, or at minimum one link wire, if I have to. So that's going to be a routing challenge. But we've got several components, large components that take up quite a bit of space, so you can open up like pins 1 to 4 of a op-amp IC by using a resistor mounted that way vertically on the board, so that the routing can come out of it, and the same up the top here. That's something I'll explore later. But for now, I'm going to leave this video here, and if anyone that's interested in this or is a little bit more an aficionado in transistor Class A amplifiers may want to actually point out some things that we can do to improve this input stage, so we get a little bit more gain ahead of this op amp, because as we saw, there's only 2 volt RMS coming out of it before clipping. Which is enough to drive any preamplifier of a stereo amp, but I did notice that my volume control had to be up about 1/3 the way before I had any decent volume output. Plus I was only using 1 channel, and quite frankly the subwoofer on the floor made it sound muddy. So yeah, the reason I'm building this is because I do have another thing sitting off to my right which I'm going to investigate on the channel soon, probably in the next video. Something I picked up on the weekend, so I can actually plug it into it. Yes, obviously it's an amplifier, but you'll see when we get to it. The next video on this, I'll explore the headphone amplifier, and there's probably only going to be 3 parts of this. This one, the headphone amplifier investigation, and the final PCB assembly and testing. But I want to make sure that we can get the design as right as possible and high enough gain, etc. So anyone's got any thoughts, let me know in the comments below. Anyway, as always, this is the Astro 3 saying thank you for watching. If you haven't done so already, please go down below, like, comment and subscribe, and that's it. You can always become a supporter on Patreon if you'd like to donate a little bit of loose change to me every month, so I can continue experimenting and dicking around with this sort of stuff on the channel. Anyway, this is Yashro 3 saying, see ya, have a great day.